Okay, the problem is maximum element after decreasing and rearranging. Where given in positive integer array ARR, perform some operation, possibly none, on ARR such that it satisfy this condition. Condition is the value of first element in ARR must be 1. This mentioned value of the first element in ARR must be 1. Okay. So this absolute difference between two adjacent elements must be less or equals to 1. So absolute difference less or equals to means at most 1. So that means it could be 0, it could be 1. So there are two type of operations possible. One is decrease the value of any element ARR to a small positive integer, or rearrange any element ARR in any order. So rearrange is simple as rearranging. Decrease means if value is, let's say, 35, we can make this value anything from 1 to 34. Okay, or minus infinity to 34. It is mentioned like they have said, like we can decrease any element of decrease the value of any element, the small, sorry, not minus n, the smaller positive number. Okay, so smaller positive number it is mentioned, so it will be 1 to 34. Sorry, my bad. So it could be any element, could be the smaller positive integer. So any number is there, let's say number k is there, we can reduce to 1 to k. So k minus 1, we can reduce to any positive integer. This range, within this range you can make any positive integer. Fine. What you have to return? We have to return the maximum possible value of element in ARR. So that means, when in another way you can say return maximum possible value of in ARR after performing the operation satisfy the condition. So maximum possible values means number of unique values in the element ARR. You have to return it. Okay, but see here it is mentioned like perform some operation, possibly none. So we can perform any number of times, right? So here they didn't ask us to return the minimum possible of operation to make the array to satisfy the condition. They didn't ask for it. They didn't ask for minimum number of operation or something. So we don't need to think worry about the operation we perform. We can do any number of time, as much of as time we want, because uh, like they don't care about number of operations we perform. They only care about the number of elements present in the ARR in the array after performing the operations. Okay, so we have to then our goal is what? Our goal is maximize the unique number in our array. That is our goal. Okay, so first of all, like they have said, like fast level must be 1. Okay, fine. So fast element must be 1. So that means what? One condition is we have to fast element must be 1. That means we cannot include 1 into the one array. So we have to change any number to 1. If 1 is present, then well and good. If it is not present, we have to make any number to the 1. Okay, fine. Then let's see some example. So these two example I have taken. This is the example it is given, and this I taken arbitrarily this example. First of all, they said in our goal, fast elements would be 1. So this 1 is present. So 1 is, I put it 1. So then my target is maximize the unique element. But see, in this case, I can maximize it. What I could do, rearrange it here. So 1, I can put this one at this one. This one I can put next element 1. So difference is what? Difference is 0. This is satisfied. It is fine because difference could be maximum 1. So 0 is fine. Then after that I can put this 2 here. So difference is 1. So it is also fine. After that I put this 2 here. Then these 2 and these 2. So this is what we are getting. So after our getting our array becomes, after performing this operation, array becomes this. So what is the unique item in this array? Unique items will be maximum number of values in the array. That means number of unique items in the array. So number of, this is the symbol of number of, so number of unique values that we have to return. That is nothing but 2. Unique is 1 and 2 values are there. Okay, let's see another example. This one. So here, like no one is possible. Like, sorry, one is not present in this area. So what is our target? Our target is first make the one. So which one should I take? So which one should I take? Obviously, the smallest number I can close to the one that I can convert that number into a one. So the smallest number is 3. So I will take these 3 and convert into 1. Okay. So what is going on then? Then I have to rearrange. So I can take 7, but 7 is not allowed. 7 is not allowed. If I do any order, if I don't follow any order, what I can do, I take 7. 7 is not if I write 7, it is not good because the difference is 6. Difference maximum 1. So 7 I can reduce to 2. 7 I can reduce to 2. Okay, fine. Next item is what? 10. 10 is what? I can reduce the 10. It's not possible. 10 I can reduce to 3. So this is the rearranging and this is the change. So 10 I have converted into the 3. 6 is not good. 6 I can convert into 4. Fine. 8 is not good. 8 and I can convert into 5. I can reduce. Let's see the problem the moment arrive. If I do start from any order, the problem arises like I cannot put 4. Okay, 4 I have to take. Let me give another good example. So let's say here it is 7, another 7 is present, then 4 is present. So if I do the continue, 7 I can rearrange to 6. Now see, whenever 4 comes, 4 I cannot directly put 4 here. I cannot directly put 4 here because see, difference is what? Difference is 2. So you will ask me, I can increase the value, but it is not allowed. I cannot increase any numbers value. I can decrease it. So I have to think further way so that I can directly get a proper approach. Okay. So how could I do that then? How could I do that? So what I can do this one. I can take 3. So 3 I can take and put as 1. Okay. Then we should take the minimum one. See, if I do the 4 first, if I do the 4 first from 7, see 4 is less than 7. Okay. So some point of time 4 can be changed and 7 can contribute to 7 here. If you notice, 7 can be 7 or 10 can be 7 if it is required. 6 can be 7. So I cannot increase the value, but I can decrease the value, right? So decrease in amount of time. So instead of taking bigger number first, whenever I have to decrease the value, I will check the smaller number, but I can decrease actually. So if I take the if I take bigger numbers first, then what happens? I am running out of option whenever we need a bigger number. So because I was utilizing my bigger number and reducing to the smallest number, whenever that number can be achieved by any other smaller number compared to my ticket. So here, so I want 3, right? So I want 3. So 3 can be achieved from 10 as well as 4. But I am using 10, the biggest number, and I am achieving this 3. But this number 3 can be achieved any smaller number compared to I have number taken. So I have taken 10, but I can use 4 to achieve this 3. So that time I have 10. So anytime, let's say I need some bigger number that is greater than this one. So I cannot increase the number, but I can use this number, right? So that's why we are taking the small. We have to readjust the smaller number first, then we'll take the bigger number. So I hope you are getting this because using this biggest number, I am limiting my capacity to reach that biggest number. So in some point of it may appear, like as I told you, it may appear like I cannot reuse the number that time. Okay, so better to use a smaller number first. Fine. Okay, so that's why I start with 3. 3 I can start with 1, convert into 1. Then I can take 4. So 4 I can convert into 2. Then what is the smaller number? 7 and 4, 3 and 4 is done. Then 6. 6 I can convert into 3. Now 7 I can convert into 4. Then what another 7 is there? This 7 I can convert into 5. Then what? 8 is there. This number I can convert into 6. Now 10 is remaining. 10 I can convert into 7. So number of unique value in this case. So number of unique values is 7 numbers is present. So this is one of the case. Okay. So what is another case? Another, let me give another example. Okay, let's take another example. So my target is what actually I'm doing. My target is always increment the value. So what I can do instead, I can put same value as well. So what actually I mean to say, remove this out example. So I can start with 1, right? As usual, I can start with 1. 3 I can convert into 1. After the minimum number is 4. I can 4 in the above you can say convert into 2. But what I can do, I can convert into 1 as well. Na? So difference is 0. Difference is 0. It is fine. So every number I can convert into 1. So that will satisfy my condition. That will satisfy my condition that it is like its adjacent numbers are absolute difference is 1, at most 1. So it is satisfied my condition. But my question is, my target is what? Maximize the unique number in there. So that's why whenever I had a chance to increase the difference, like whenever I had a chance to increase the difference in the sense, increase the like number. Whenever I have a chance to increase the number, then I'll do that thing. Okay. So for that, that's why I start with 3 to the 1. So obviously 3 to the 1 I have to do because it is given first thing must be 1. So after that 4 I am taking next smaller number. Then I'm converting instead of doing that 1, I'm converting into 2. I have the chance to create a new number. You can say I have a chance to create a new number. Then I'm but if that is no chance, then we can't create it. Let's give an example. This example. So let's start from our usual technique. So I have to take the smallest number. So see, the order is what actually I am doing here. I am taking every time a smaller number. Every time I am taking a smaller number, like in the smallest number order. So that means I need a one order from smallest to the largest order, right? Every time I am doing that thing. So in that case, what is the best approach to this? Obviously, best approach is sort the element. So first sort it. So it will make like how could I find element like this is my current smaller, then I have to find the next current smaller, then I have to find the next current smaller. So best way to achieve that thing is getting the sort operation. Okay. So okay, 1, 2, 3, 4, 1, 2, 3, 4, 3. Yeah, this is actually that should. Okay, fine. Then let's sort it. If I sort it down, it becomes 2, 3, 4, 4, 6, 6, then 11. This is my sorted array. After that conversion becomes easy, I just have to convert the number. So to a fast, by default, fast element would be 1. So see, in the constraints are linked to 10 to the power 5 and maximum element is 1 to 10 to the power 9. Obviously, so there will be some 1 will be present. If the 1 comes after sorting, if first element becomes 1, it's fine. We are converting 1 to 1. Other than that, if it is any other digit, then it is very good actually. Okay, so I can first 11, I can 1. So 3 I can convert into what? 3 I can convert into actually 2. Previous element plus 1 I can convert. I will check what is the current 3. If 3 is matching the condition, like difference is same or not. If it is greater than 1 or something, if it is greater than 1, then it's fine. I will convert it. But if it is equal, but I will not convert. So just a minute. Example is not good actually still now. Okay, let me put another 6 here. Another 6 here, and okay. Fine. So what actually I am doing, the 3, I will check 3 whether the condition satisfied or not. If it is at most 1, I will leave it. If it is not at most 1, I have to make, I can decrease the number. That means 3, check the condition, it is exceeding the at most 1 case, right? That means I can reduce the 3. I can reduce the 3. Okay. So I can reduce the 3 to 2. Current one plus 1. So obviously whatever the number will form, that will be obviously less than my 3. That is for sure. So I am making a previous element plus 1 item, and before that I am checking that my current item is greater than the previous item or not. Previous item, how much greater? Much greater than, like difference is greater than 2. Sorry, greater than 1. Difference is, absolute difference is greater than 1. That's why my current item will be always smaller. So no need to think of it. Fine. 4 it will come. It will check whether difference is not good or not. Difference is okay or not. Difference is not okay. Then make 2 plus 1 3. Now let's check this 4 about this 4. 4 is already satisfying. Already satisfying. Okay. So 4 is already, I have added one new element, nah? So that's why I added this extra 6. So this 4 is already satisfied, right? 4 is already satisfied to the condition. See, 4 is 3 plus 1 equals to 4. 4 is already satisfied. Okay. So I cannot decrease the value. 4 is already satisfied. Fine. Cool. So what happened? 4 will not change. It will be 4. Now comes to 6. This 6. This 6 is again greater than the like the absolute difference is much greater than 1. So that's why it is become 5. 4 plus 1 5. Fine. Still now it's good. Still now it's good. Now this come to this 6. This 6. And this 6. How many you can see this 6 is nothing but I can put 6 again, because see the difference between 5 and 6 is simply at most 1. So I cannot decrease the value of 6. It's 6. Now see this case, this 6. This 6 difference is 6 plus 6 is 0. Difference is 0. But I want the maximum number possible. If it is any number, if it is, what is my idea, like what is my current goal or what I actually want to do, I have to make difference actually, create a difference so that I increase the unique numbers in my array. So I will try to increase, I to make this 6 to 7, but is it possible? I cannot increase the value 6. I cannot increase the value 6. That is not possible at all. I have to return whatever the current value is. So after a certain, I can reach one place. I can reach one place where I cannot change my value. I cannot change my value. I have to fix the value. I have to put this value 6. So I will put the 6 here, because see, it could be the similar but cannot exceed. It could be the similar but cannot I cannot increase. So that's why it becomes 6. It becomes 6. Okay. So then the 11 in the case I have to put that it is 7. So this is the case. How many unique items? You can see number of unique items is 7. So what is the easiest to find out how many unique items are there? You can see the last digit is the maximum number. So I am starting from, obviously I am starting from 1, and that is the last digit. This is the last digit present in my array. So that means that many unique numbers are present in my array. Easily we can return the last element of the array after we performing some those operations. Okay. So you can see we are always starting with 1 now. So obviously and we are not skipping any number between that. You can do the same. You can put the same number multiple times, but we cannot skip any one number. So that means if you want, let's say you want to skip 5 here, the difference between 4 and 6 will be what, 2. So that means what? Obviously the from the first number to the last number, we cannot skip any digit. We cannot skip any digit. We can put same digit multiple times, but we cannot skip any digit. So number of unique element will be the last item of this array. Fine. So number of unique elements will be 7. So see this example. See this example. What happens here? I just rearrange it that time. Now. So if you don't rearrange that time, you just sort it. Sorting is done. After sorting, so this is the thing. After we get after sorting. So if you do our algorithm, so after the sorting, if you get the algorithm, what will happen? The thing will happen. Like if I convert this one, I have to put this one as one, mark this one as a one because starting item must be one. So in respect of it is one or not, I can put this one. If it is one, it's fine. We are replacing one by one, and if it is any other digit, then we are replacing to the one. So next time, whenever come this one place, this I will check. I want to make this as a two. I want to make it as a two, but it is not possible because the same is it is a similar size is like absolute value is zero. Absolute value is zero, so I cannot change. So I can change actually when the absolute value is zero, I can change, but the thing is I cannot increase the value. So whenever absolute value is zero, actually the item becomes similar. So the case is whenever my absolute difference is zero, that time I cannot change the value. So that means whatever the previous number is present, this is my current number. So that means I cannot increase the value. That's why whenever absolute value or difference becomes zero, then I cannot increase the value. I have to put the same value. Whenever my difference is exceeding one, then only I can reduce. Otherwise, if it is absolute value is one, then is what? It is already incremented. See here, in the next case, 2 becomes, I will put 2 because what? If see the difference between 1 and 2, absolute value is, the difference is 1. That's what I need. I need my target will be, it will be kind of a greedy process. My target is create an absolute difference of 1. Always create absolute difference of 1. If I can't create absolute difference of 1, then I'll put the difference of 0. But if it is by default, it is absolute difference is 1, then why do check of it? Okay, fine, I'll make this 2. Now these two difference is same. I cannot increase. So whenever difference is same, that I am forced to put the same number of the previous number. I'll put the same number. Similarly, this two also I'll put, and this two also I'll put. Even the sorting I can get the item, but still I can get these many numbers. Like this is a after operation also. This is the number of item, and then I return the last number is 2. So I'm starting from 1 and ending at the 2 right now. So how many items are there? 2 unique items are there. So that's we can return. Hope you understand the process. This is the approach. So let's write the pseudo code. So let's say function, let's say find maximum values, given one array is given error. So what you have to do first, simply sort the array. Error dot sort. As I told you, I have to sort the array. After that, I have to first condition is first element must be 1. So error of 0 must be 1. So that is done. So I'm starting from the second element. I have to check whether it is satisfying the condition. Otherwise, if it is more than 1, then I will put the previous element plus 1 kind of concept, right? So as I told you, so starting for I equals to second element. So that means 1 index number 1 to I less than n, then I plus plus. I'll do this. After that, what I will do? I have to check one condition. Check condition in the sense. Okay, just a minute. Let me connect my cable, charging cable. Okay. So if my previous element difference absolute different ABS, and it is already sorted now. So if it is already sorted, that means previous element cannot be greater than my current element. So it is sorted, and obviously I'm starting with this 1, so it is not at all possible. So I'll simply do not absolute is not also required. I can simply put it here. If my current, so ARR of I minus ARR of I minus 1. If it is difference is greater than 1, if that is greater than 1, so I have to reassign the value. What is the reassigning value will be? The reassigning value will be ARR of 1 value will be of ARR of I minus 1. What is the previous value it is? Then plus in one value increment of that. So that difference between one and I get a one unique number. I will not make it equals to error of one. So if it is same, if it is equals to 0, then it will be the same value. I cannot change. If it is equals to one, like difference is one, then also it is fine. I will not change. If it is whenever the my current number is more than there is a difference of 2 than compared to its previous number, whenever the current numbers and its previous number difference is 2, then only I will change the value. I will make this value, otherwise I will not do anything. Fine. So this is what I will do, and that's all I needed. So the for loop also ends. At the end, as I told you, I had to return the last element of the array. So return ARR of, what will be the last element? Okay, I put is n here, but I didn't calculate n. So you can calculate n. Better to calculate, it will be easy to understand. Forget to calculate n here. So n is nothing but length of the ARR. So n is nothing but ARR dot length. Okay. So I will return what? Return the last element n minus 1. Very simple problem it is. That's all. Time complexity. This sorting takes big of n log n time. N log n time. This for loop takes big of n time, obviously, and otherwise all are the constant there. So time complexity becomes big of n log n, because that is the maximum, n log n, and space complexity is, you're taking any extra space, no, the same array I'm reusing. But one thing you have to say in the interview, like array, whenever we sort the array, sometimes sometimes not, sometimes always, it takes some extra space. So we have to, if you exclude the extra space needed by the array, then we can use big of 1. Otherwise it will be big of n. If you include the sorting, like space required for sorting, that's why it is big of 1. So if you exclude that extra space for the sorting, then it's a big of 1. Okay, hope you get it. This problem, it is very easy problem. Okay, then as always, if you are getting any mistake in this video, please let me know so that I can rectify. And if you find any useful information on this topic, please also let me know so that I can learn. Thank you. Bye bye.